Action! Click. Where's the board?
Right there.
Take 3.
All right, so earlier Steve taught us how to set a bridle point, and we did everything manually because after all we're in school, right? So basically our chalkboard's on the floor, and we got our parameters, our reference distances at the beginning, including the distance from the ground to the low steel and the high steel. And we wrote those values on the ground over here. Well, Steve, when you're out doing 150 points, obviously you're not going to do it like this, old school chalkboard way. We're going to do it on the computer in a spreadsheet. And Steve has a rigging spreadsheet set up that receives values from the Bluetooth function of the DISTO. So basically, you can set your points and get all the distances that we worked out here on the ground as fast as you can take the measurements once you have your reference parameters set.
Just one click. And I can go from one point to the next point, to the next point, to the next point, and it'll all be brought right in here, and it'll calculate all the bridles, the tension, all at one click.
Cool, show us how it works.
Okay, so what we did, we took all the parameters that we had here, the LS, which is the low steel of 13 feet, the HS, the high steel at 18 feet 6 inches, the distance between the two beams that we are going to bridle from downstage to upstage, which is the 22 feet. We inputted those values right into here. The high beam is 18'6", the low steel at 13 feet on one side. On the upstage side, that beam is 18'6", the low steel is 13 feet. The distance between the two beams is 22 feet, and we're going to hang the chain hook of the hoist at 8 feet off the ground, so the B dimension of the Pythagorean theorem is going to end up being 5 feet. Side here to the crosshair here, I've got the target set up right there, and I'm going to shoot right to that. So what I've done is by pushing on the blue arrow, which is our Bluetooth, it transferred that 8'3" and 15/16 over to the iPad into that cell. And it's already calculated all the bridle lengths. We're going to go to point number 2, and we'll shoot right at the target. Get a measurement. I'm going to push that right over to the iPad. It calculated that point. We'll go to point number 3, make a measurement. That's 13'6" and 7/16. We're going to push that by pushing the blue arrow. If you want to go to high steel, high to high, it's already giving you that calculation here. If you want to go from low downstage to high upstage, it's giving you that calculation.
So you're dead accurate based on laser measurements.
Exactly.
So in a, say, 100-point setup, how much time do you think this could save you?
Tons and tons of time. I'll put that in there. And what I'm going to do on this one here, since we don't have a lot of weight for this chain, because we're not going to take it up very high in this building here, we're going to put a 50-pound weight here. Just to, so it gives it some weight. So it can pull down on both legs. And this is just for the class only. Normally, in an arena, we wouldn't put a 50-pound weight right here.
Yeah, I was going to say, just for an extra workout. Yeah. You got a really fast student who's losing pounds during the course.
But what happens is on a chain for a Lodestar hoist, it's a pound per foot. So 50 pounds of weight is like pulling up 50 feet of chain.
Okay.
So that's why I use a 50-pound weight here, because I test the student's ability to actually, if you can't pick up 50 pounds, you're going to have to get into the gym and start working out if this is what you want to do for a living.
Right.
So now I have representing 50 feet of chain with this 50-pound weight here, and then the chain right here will be our plumb to see if we get it right on that spot right there.
Got it.
Okay.
Somehow I have a feeling we're going to get it right in that spot.
It'll be. We'll see. I'll take the bag out, put it in front of me. This is why I need a 3-foot bowline. Has to be a right side length. I get my foot into it, now I can hold everything. Now the cable, that's why we don't put this cable to this loose shackles, because I got to get the cable around the beam. Bring it around, the other side here. I'm going to attach this loose shackle to this cable here. This is where, you know, doing a practice and stuff up here with the students, telling them you can't drop a shackle pin or bellow the shackle, because if that hits somebody on the ground, it could kill them. So I'll fold the burlap. Again, the burlap is only to protect the abrasion of the steel cable against the steel beam here. The ground rigger is just as important as the high rigger. So it just looks like I have to go on stage just a little bit. Not bad, huh?
Oh, it is about 3/8. It's the width of the chalk line.
Numbers are important. So when you're talking about, you know, having a house rigger give you what the height is from the floor to the bottom of the steel, and what the distance from this steel structure to that I-beam there, you want to go by him, you can do that, but he may be off. So I don't take that chance. That's why I have my Leica with me all the time. I don't leave home without it. And that's the truth. I do not leave home, I do not leave this shop going to a job site without that laser. It is the #1 piece of equipment I have in my rigging bag.